So the mechanism of the reaction was that there was a double bond, and the electrons would get attracted to the positive electrophile, which is H positive in this case, and a carbocation would be formed. Now, what does that have to do with the Markovnikov's rule? And we're going to understand why this happens. So the first thing is, whenever you have a double bond and HBr is getting added, or any unsymmetric alkene, and an addition reaction is happening, the H would always bond with the carbon that's already bonded to more H atoms, which in this case is the right one, because there's one H over here and there's no H over here. So that is going to be your major product, and the other one is going to be your minor product. Uh, the two positions could be switched, and that would result in the minor product. Okay, Abba, is this clear? Markovnikov's rule. Rida, Heba, is that clear? What was Markovnikov's rule? And so now the explanation for the Markovnikov's rule, and you will be asked about this. Okay, this is part of your syllabus, and recently you have gotten questions for this. So explaining Markovnikov's rule. So what happens during the electrophilic addition? Why does the H like to bond with the carbon that's already bonded to more hydrogen atoms? So we're going to take an unsymmetric alkene, and let's say that there's an addition reaction. Hydration is happening. So let's say hydration is happening. In hydration, you have an H plus one from the acid that comes along, and that H plus one acts as an electrophile, and it's going to attract the bonded electrons towards itself. So the bonded electrons are going to get attracted. So here's your double bond in the middle. That's the first step. And this H plus one is going to pull all the electrons in the pi electron cloud towards itself. So two things could happen. There are two types of carbocations that can form. One of them is that you could have the double bond is going to go away. Why would it go away? Because the H plus one would attract it. So there's an H plus one, and that H plus one would attract the double bond, and all the electrons in the double bond in the pi electron cloud are going to get attracted towards that H plus one. So the H positive charge would go away, and the carbon over here would become a carbocation because the H took its electrons away. The other thing that could happen is the other thing that could happen is that instead the H could bond with the other carbon atom. So the other possibility is that you could have CH3 and C, and there's a double bond in the middle, and you have hydrogens, and the H plus one can come in, and it could now bond or might bond with the other carbon atom. It could pull the electrons in the double bond. So let's say these electrons have been pulled towards H, and it ended up bonding with the other carbon atom. The positive charge on H would go away, and this carbocation would be formed. So there are two possibilities. And in the next step, let's say OH minus one comes in, and the so in the next step you could have your OH minus one or water molecules coming in, and they could complete the addition reaction. I'm not drawing the complete mechanism. I'm just showing that that's how an addition reaction would happen. Anyways, I'm not really interested in this OH coming along. So this is what's happening. So what is the Markovnikov's rule? The Markovnikov's rule is that the H atom likes to bond with the carbon that's already bonded to more H atoms. So can anyone tell me which one would it be? Would it be this one or would it be this one? Right or left?
Right.
Okay, it's going to be the right one. Okay, which is so this one is going to be your major product. This one is the one that's more likely to be formed, right? According to the Markovnikov's rule. So the issue is, why is this more likely to be formed? And the answer to that is that you have to go into a bit more detail. The answer to that is that if you look at both of these carbocations, so there's this one and then there's this other carbocation. So have a look at both of them. They're not exactly the same. The positive charge is not exactly the same. Let me make this bigger. So the positive charge is not exactly the same. One of the positive charge is actually bigger than the other one. I mean, they're both positive. I'm talking about the charge density. One of the positive charge is bigger than the other one. So what I'm going to do is, let's focus on the positive charge over here, the first one. How many electrons is it surrounded by? I mean, there's a carbon atom on the left side. So okay, so there's a carbon atom on the left side. So that gives you 6 electrons. There's a hydrogen atom on top that only has 1 electron. And there's another carbon atom to the right. So that's another 6 electrons. So why am I writing that? The reason I'm writing that is that the immediate neighborhood of this particular positive carbocation is surrounded by 13 electrons. So there are 13 electrons right next door. A carbon next door, carbon over here, and a hydrogen over here. So all these electrons, because of the positive carbocation, they're going to be pulled towards this positive carbocation. All of them. Because, I mean, right in the middle of the molecule, there's a positive charge. So that positive charge is not going to just remain there. It's going to pull the neighboring electrons towards itself. Okay, so that's one thing. Look at the other carbon and look at its immediate neighborhood. There's 1 electron over here, there's 1 electron over here, and there's a carbon atom over here, so that's 6 electrons. So again, this carbon is positive, so it's going to pull all the electrons. I mean, it wouldn't be able to pull them because the nucleus of the other atoms are also pulling electrons. So it won't be able to actually pull all of them, but the electrons in its immediate neighborhood would be slightly closer to the positive charge. There's a positive charge sitting in the middle, and the electrons in the immediate neighborhood would be pulled towards that positive carbon. Achha, out of the two, which one has more electrons surrounding it? This one or this one?
Left one.
ठीक है, the left one, because there are 13 electrons. I mean, if you have more carbon chains, there are more electrons around it. ठीक है? So this one has more electrons surrounding it. And if there are more electrons surrounding it, there are more chances of the positive charge being smaller. I mean, there are more electrons, right? The more electrons, they get pulled towards this positive carbon atom. So the positive charge would actually be having a lower charge density. It's going to be much smaller because it's surrounded by a lot of electrons. This positive charge over here is actually going to be relatively larger in size. Is this point clear to everyone? Abba, is this clear? Minahil, is this clear? Hiba, Rida, is this clear?
Yes.
Okay. So now this,
Yes.
so this thing over here is the main reason why one of them is stable and the other one is unstable. So now just focus on this, that this one has a positive charge, right? So the issue is, why did it get a positive charge in the first place? Who was taking electrons away from it? It was actually this hydrogen atom that was actually pulling the electrons. So let's start all over again. Think of this positive charge as being very large. So the electrons go back, right? The positive charge is no longer over there. The positive charge was actually on this. Let me. So the positive charge was actually over here, right? So initially the carbon didn't have a positive charge. This H plus one came along, pulled electrons away from that carbon and took its pi bonded electrons. So the positive charge went from here to over here because, I mean, it got its electrons. The other one is now short of electrons. But the issue is that if the positive charge is lesser, if the positive charge is very large, it won't let the hydrogen atom take those electrons. because the positive charge would be so large that it would pull those electrons back so that H would not be able to actually take those electrons in the first place. Is this point clear, Bazra, Ibrar? Is this clear, Minahil?
Yes, sir, clear.
ठीक है, Abba, is this clear? ठीक है, so I'm just going to repeat it one more time. ठीक है, Hiba, Rida, is this clear? Acha, so anyway, so I'm just going to repeat it one more time. ठीक है, first thing is I think this was clear that the positive charge on this carbon atom had a much greater charge density because it wasn't surrounded by a lot of electrons. So I mean the positive charge in the middle of the molecule was kind of stronger. So just explaining it once more, that the H plus one, why did the carbon get the positive charge? Because the H plus one was pulling electrons away from it and taking those electrons away from that carbon atom, and the carbon got a positive charge. And the whole issue was that the carbon had such a strong positive charge that it's going to not allow the hydrogen to take those electrons, and it's going to pull those electrons back. So that means the reaction wouldn't really start, wouldn't happen, or the probability of the reaction happening in this way would actually be lesser. And so since it's larger, I mean the carbocation, I'm going to focus on the carbocation now. Since the carbocation had a larger positive charge, get this back. Hence, this carbocation was unstable. What the word unstable means that it's going to change quickly. I mean, it's not going to form. I mean, that is what unstable is. That it would be very unlikely that this carbocation is formed because the positive charge is very large, and it would be difficult to form this. This one would be easier to form. That if the H pulls the electrons away from this carbon, the positive charge is not. I mean, the positive charge over here, the carbon over here, can get electrons from somewhere else. I mean, there's so many electrons around it. So it won't be bothered with the H stealing its electrons. It can pull electrons from other places. So that's why that carbocation is more likely to form. So I'm going to write this now. I'm going to write the explanation, uh, which is which is simply that carbocations. I mean, this is what you're going to write in the paper. So carbocations with more alkyl chains. So carbocations with more alkyl chains. Just 1 second. Are more stable as alkyl chains have electron donating effect. So they have electron donating effect, and which reduces charge density. So that is going to be your explanation for the Markovnikov's rule. That why does this happen? Because of this thing. ठीक है? Ibrar, is this clear? Minahil, clear है?
Yes, sir.
So ठीक है, we're done with the Markovnikov's rule. And we're done with electrophilic addition. Uh, we did a lot of things in electrophilic addition. We did a lot of addition reactions. We're done with most of them. The next thing about alkenes is alkenes is a big topic. Okay, so the next thing about alkenes is we're going to talk about oxidation of alkenes. So we're going to talk about oxidation of alkenes. Now, what happens to oxidation of alkenes? Remember, you haven't studied oxidation of alkenes in. I mean, this is you're familiar with this, not this thing, but the electrophilic addition reactions, bromination, hydration, with hydrogenation. You are all familiar with those reactions. Oxidation of alkenes you haven't studied. So remember, alkenes they get oxidized, and there are two types of oxidation. Number one is called mild oxidation. That's kind of easy. Okay, once we are done with alkenes, we're going to do a very we're going to do some past papers related to alkanes and alkenes very thoroughly. Uh, so mild oxidation is that the oxidizing agent that you use that's cold dilute as alkaline KMnO4. Now remember that KMnO4 is an oxidizing agent. This is potassium magnate 7. The potassium is irrelevant. That's just a spectator ion. It's magnate 7. So magnate 7 ions are your oxidizing agent. They're purple in color, and usually in this reaction, they don't actually get fully reduced. They change to brown or maybe light pink, which is usually written as colorless. I mean, Mn goes from +7 to +4 to +2. So you have MnO4 -1, they get reduced to MnO2 and then eventually to Mn2 plus ions. Uh, so cold dilute alkaline KMnO4, that's your that's your oxidizing agent. What happens when you use cold dilute or mild conditions? What happens to an alkene is that it's a simple reaction. Diols are formed. So if you have an alkene, let's say you have propene. So wherever you see double bonds, it's like an addition reaction. Or it would represent the oxidizing agent, which in this case is cold dilute alkaline KMnO4. And this is what would happen, that the double bond is going to go away. And OH groups are going to get added to both carbon atoms. So diols are going to be, they are going to be formed. Okay, it's a simple reaction that's going on. Focus on these two carbon atoms that are forming the double bond, and the two carbon atoms would eventually not form a double bond. Instead, they're going to form a diol. Okay, is this clear? Minahil, is this clear? Abba, is this clear?
Sir,
Yes.
why have you written this oxygen in brackets?
Nee, that just represents the I mean, that's the way to represent an oxidizing agent. Okay.
Sir, where did that H come from
Nee, there's
with
water
the
as well.
OH?
मतलब पूरा KMnO4 है ना.
Acha, okay, okay.
ठीक है. I mean, it's not. I mean, you're not writing the whole equation. ठीक है. I mean, it's not even an equation. It's just an alkene reacting with an oxidizing agent and forming a diol. ठीक है. So there's KMnO4 alkaline का मतलब है there is OH ions as well. Dilute means there's water as well. So there are lots of things. It's a whole equation. So let's do another example. Let's do some skeletal formulas. For example, I have a molecule where I have. So mic किसी का on. So let's say there's this molecule, right? And it undergoes strong, not strong, mild oxidation. So what would be the product of the reaction? The product of the reaction would be that first thing is I'm going to draw this again. So the product of the reaction would be wherever you had a double bond, OH are going to get added to those places. So there's going to be another OH and an OH over here and an OH over here. So all those places where you had double bonds, now you have OH groups attached. Okay, that's one thing. Is this clear? Okay, simple reaction, nothing too complicated. ठीक है इब्रार clear है मिनाहिल clear है
Yes.
अच्छा the next part is the complicated part which is strong oxidation ठीक है and you have to focus on this very carefully ठीक है make sure you don't make any mistakes so the second one is your remember I'm telling you again keep revising organic ठीक है there's a lot of reactions make sure you write very good notes look at organic chemistry at least for 5-10 minutes every day but get twice a day so strong oxidation और जब मैं कह रहा हूँ ना कि just have a look at it मतलब you don't even need to study it ठीक है per se you just what you just do is just go through and look at the pages just for 10 minutes uh, because you're going to forget all of this very quickly if you don't do that अच्छा so strong oxidation is in strong oxidation you have the conditions for strong oxidation are that you use concentrated uh, opposite होगा it's going to be hot concentrated and acidified KMNO4 so you're going to use hot concentrated acidified KMNO4 so obviously the conditions are strong now the first thing that's going to happen is so remember the whole reaction would be around the double bond nothing should happen to the rest of the molecule uh, nothing should happen to the rest of the molecule this is what a double bond looks like all double bonds look like this they have a double bond and carbon is bonded to two other things so in each case what's going to happen is that the double bond is going to completely break it's going to be I mean the whole molecule would split into two parts wherever there's a double bond there's going to be the bond is going to completely rupture and the molecule would split into two parts and there would be three scenarios scenario number one is that when the double bond breaks the carbon one of the carbons with the double bond is bonded to two hydrogens so that's scenario number one this thing will get oxidized but it will get oxidized to a carbon dioxide molecule so that's the product if you have an alkene that looks like this I mean the double bond is
Sir,
going to
can you
break
repeat this? मतलब जहाँ पे you were saying कि can you repeat this कि
I mean
मतलब the double bond breaks and then फिर क्या
हाँ
होते हैं मतलब?
मतलब whenever for example over here right in this case the double bond is going to completely split or break in the middle ठीक है and the molecule would split so the carbon
So does that mean कि it turns into a single bond कि नहीं मतलब
नहीं
basic
not
it is a
not
double
not
bond
single bond it completely breaks
अच्छा alright.
ठीक है so it completely breaks so that is what is meant yani the molecule splits into two things you're going to get multiple products ठीक है there would be it would be splitting into two completely separate things अच्छा so one scenario number one is that once the double bond has broken away this is I mean you get this residue and this thing would get converted into it would be converted into a carbon dioxide scenario number two is that the double bond breaks and the carbon on one side is there's a carbon chain R represents a carbon chain and on the other side you have an H atom so that is scenario number two now this carbon atom would first get converted into an aldehyde so it would change into double bond O and H and there's going to be an R group but it would eventually get converted into a carboxylic acid another oxygen will get added to it more oxidation would happen and it would form double bond O and OH and R. So that's basically a carboxylic acid. This is an aldehyde. So this one is an aldehyde, and that over there is a carboxylic acid. I mean, it's C double bond O and OH. So that's a carboxylic acid. This one is an aldehyde. So remember, everything is happening to the carbon that was previously making a double bond. But now that carbon is changing into an aldehyde, and then it's further changing into a carboxylic acid group. Now, next one, number three, scenario
If we
number
have
three.
both R's,
Hmm? Or,
if we have both R's.
हाँ, उस पे आ रहे हैं, the third one. So the third one is that you have a double bond, and the carbon on both sides there's a carbon chain. ठीक है, that's number अच्छा that is number three. ठीक है, इसको इधर कर ले. अच्छा, that's number three. This thing will get converted into a ketone. So this thing over here gets converted into, it's RC double bond O and another R. It changes into a ketone. So three things can happen. Okay, first thing is double bond breaks completely, and let me write that down as well. Okay, so complete splitting of the molecule. So the double bond splits completely, and three scenarios. One is that the double bond carbon has two hydrogens, gets converted into a carbon dioxide molecule, has a carbon chain on one side, gets converted into an aldehyde, and then a carboxylic acid. Ignore the aldehyde, actually, it just gets converted into a carboxylic acid. And the third one is it's going to form a ketone. If they are on the carbon, there's carbon chains on both sides. So I'm going to do the first molecule first. Let's try and oxidize and do strong oxidation of propene. So the first example is a propene molecule.
Sir, won't this ketone undergo further oxidation?
No, ketones are resistant to oxidation. ठीक है, they
अच्छा,
don't they don't get
जी
oxidized. अच्छा, so let's talk about propene. ठीक है, so here's my propene molecule, and let's figure out what's going to happen. First thing, the double bond is going to split in the middle, so this double bond breaks completely. Now focus on this carbon atom. ठीक है, the rest of the molecule would remain exactly the same, only change this carbon atom. मुझे बताओ, which option is this? One, two, three में से which one is this?
First, first
option A.
ठीक है, so this part would get converted into a carbon dioxide molecule, and you can also add a water molecule. ठीक है, उधर भी I'll add carbon dioxide and water. अच्छा, now focus on this carbon atom. What would this change into?
second
Aldehyde
carboxylic
and then
acid.
carboxylic acid.
ठीक है, so it's this option. It's this option, which is that the carbon is connected to a carbon chain on one side and an H atom on the other side. So carbon chain and H. So this one would get converted into a carboxylic acid. Okay, so redraw the molecule as it is. I mean, there's going to be CH3. The only thing that would change is that the carbon that was previously making a double bond would change into a carboxylic acid. It would change into C double bond O and OH. Okay. Is this clear to everyone? Minahil, is this clear? Aba, is this clear? Rida, Hiba?
Yes.
Yes.
Sir, aren't we supposed to mention the part of the aldehyde where it first converts to an aldehyde and then to a carboxylic
No,
acid?
eventually, most of the time you just have to write this one.
अच्छा,
Okay.
अच्छा,
Uh, there's only one way that an aldehyde could be formed, actually, which is that if you somehow remove the compound from the mixture, like if aldehyde is formed, you somehow get rid of the oxidizing agent. Okay, we'll talk about that later. Okay, right now just think of it as forming a carboxylic acid. Okay, so is this clear?
Yes.
Just 1 second. So let's do a more. Trouble would be the skeletal formulas. Okay, let's try and do some skeletal formula and try to oxidize them. So you have a molecule of there's a cyclohexene. So let's say there's this molecule and it has a double bond over here, and there's a carbon chain over here. Okay, let me make this bigger. Now I want to oxidize this. First thing, the problem with skeletal formulas is they don't show you hydrogen atoms, right? So you have to figure out. Remember, everything that's happening is happening to the carbon atoms which are attached to the double bond. So I'm just going to highlight them. These two carbon atoms, let's focus on them. The double bond would split, right? How many H atoms is this carbon atom bonded to?
Two.
Okay, so it's bonded to two, like it's already forming a double bond. So there would be two more H atoms. So this is which scenario is this one? What would this carbon atom get converted into?
The first one.
Okay, so this one is the first one. It would change into a
Carbon dioxide and water.
carbon dioxide and water. Okay, so that's one thing. Scenario number one. That's carbon with two hydrogens. The next one. What about this one? I mean, how many H atoms would this be bonded to? This one over here.
Only.
TK, it would be bonded to one H atom. Because the easier part to remember is what you can do is you can just count the H, forget the carbon chain. If it's bonded to two hydrogens, then it's carbon dioxide. If it's bonded to one hydrogen, then it's an aldehyde and then a carboxylic acid. And when there is no hydrogen, then that means it's a ketone. Okay? So the easier part is forget the carbon chain, just count the hydrogen atoms that are attached to it. Okay? So this one, if it's one H, so it should change into what thing? It should change into a carboxylic acid. Now, I'm not going to draw the entire thing right now. Just wait 1 second, okay? Uh, what about this part? So I'm going to change it into a carboxylic acid. What about this part? This carbon atom.
Ketone.
Okay, so if you focus on this carbon atom, it's already bonded to four things. There is no H over here. If there is no H, then it would form a. I mean, this one is going to change into a ketone. And this thing over here, this carbon atom over here,
Carboxylic acid.
okay, that would change into a carboxylic acid. So let's start redrawing the molecule. Okay, now without the double bonds. The double bonds are going to go away. So I'm going to redraw the molecule. Okay, just give me 1 second, quickly redrawing this. First, I'm going to redraw everything. So this was how the molecule actually looked initially, right? You got rid of the double bonds. So I'm going to draw the final product now. Now you got rid of the double bonds. So the double bonds are gone. I mean, you had this carbon atom and this carbon atom. The double bond went away in the middle, right? I mean, this carbon atom changed into a carbon dioxide molecule. whereas this carbon atom got converted into a carboxylic acid. So that's C double bond O and OH. Okay, so that thing is gone. The carbon dioxide has broken away. What about this one? The double bond in the middle. Let me draw the carbon atoms. The double bond in the middle went away. This carbon atom changed into a ketone, so it's C double bond O, and this one changed into a carboxylic acid, so that's C double bond O and OH. Now focus on the fact that I haven't changed anything else. All the bonds are all there, everything is there. The only thing that's changing is whether I'm converting, I mean, the double bonds are gone, so erase all the double bonds in the middle. So I've gotten rid of them. There was one over here and there was one between these two. So I've gotten rid of them. The rest of the molecule remained exactly the same. This one over here changed into a carboxylic acid, which we figured out earlier. This one changed into a ketone, so I drew a ketone. This one at the end over here changed into a carboxylic acid, so I drew a carboxylic acid over here. And the carbon dioxide molecule broke away. Okay, this end one changed into a carbon dioxide molecule. So is this clear to everyone, Ibra? Is this clear? Mirahil, Aba, is this clear? Rida, Iba, is this clear?
Yes.
Okay. So this is strong oxidation. There's nothing else about oxidation of alkenes. This is all there is. There's mild oxidation, which is easy. If you're doing mild oxidation, just get rid of the double bond, turn it into a single bond, and add OH on both sides, and there would be OH on both sides. But if you're doing strong oxidation, the double bond is going to completely go away, and the molecule would break at that particular point. So there would be nothing in between these two carbon atoms and these carbon atoms. And you have to figure out what the products are. So we're going to do more questions like this. Try and send me as homework, or if you have time, you can try and do this right now. Try and send me what is the product of. So what's, I mean, there's this molecule that I'm drawing. Yes. So this is the molecule. Tell me what the product is of strong oxidation. Okay, just 1 second sharing it. Okay, that's your homework. Try working this out. What would be the product of the oxidation of this molecule? Okay. So uh, we just left with addition polymerization of O levels. Okay, nothing different there. It's PVCs वगैरह. ठीक है, वो you have to study that in alkenes. Otherwise, we're done with alkenes. We're going to start doing past paper questions of alkanes and alkenes uh, probably in the next class then. Okay. So, okay then. If you have, does anyone have any questions about this?
No, sir.
चलें ठीक है. Okay then. Take care.
Chalo, Allah Hafiz.
Allah Hafiz.